To determine if a 600 amp section with room for a 220 amp 3-phase sub-feed breaker is sufficient for 660 amp 208 volts flashes and 330 amp 208 volts machines, firstly calculate the total load of the flashes. Since there are 660 amp flashers, multiply 6 by 60 amps, which equals 360 amps. Secondly, calculate the total load of the other machines. There are 330 amp machines, so multiply 3 by 30 amps, resulting in 90 amps. Thirdly, add the load of the flashers and the other machines to find the total load. The flashers contribute 360 amps and the other machines contribute 90 amps. 360 amps plus 90 amps equals 450 amps. This is the total load that needs to be supplied. Now determine the ampacity of the feeder. A 220 amp subfeeder breaker can only supply up to 220 amps. Compare the total load, which is 450 amps, with the ampacity of the subfeeder breaker, which is 220 amps. The total load of 450 amps is greater than the ampacity of the subfeeder breaker, which is 220 amps. Therefore, the 600 amp section with room for a 220 amp subfeed breaker will not be big enough to handle the load of 660 amp flashes and 330 amp machines. A larger subfeed breaker and feeder will be required. Upgrade the subfeed breaker to at least a 450 amp breaker and ensure that the feeder has an ampacity of at least 450 amps to safely power all the machines. Consider consulting with an electrician to verify the specific requirements for the setup. In summary, the existing 220 amp subfeed breaker is insufficient for the combined load of the flashes and other machines. A larger breaker, rated at least 450 amps, is necessary. The feeder conductors must also be sized to handle at least 450 amps. It is important to consult with a qualified electrician to ensure compliance with local electrical codes and safe installation practices. Consider factors such as voltage drop, conductor installation type, and ambient temperature when selecting the appropriate feeder size. It is critical to select components and perform installations in accordance with the National Electrical Code, or NEC, and any applicable local codes to ensure safety and proper operation of the equipment. A load calculation considers the continuous and non-continuous loads to determine the minimum ampacity of the service. Continuous loads are those that operate for 3 hours or more. Non-continuous loads are those that operate for less than 3 hours. The NEC requires that continuous loads be multiplied by 1.25. For example, a 100 amp continuous load requires a circuit breaker and conductors rated for at least 125 amps. The total load is the sum of the continuous and non-continuous loads. The service entrance must be large enough to handle the total load. The size of the service entrance is determined by the ampacity of the service entrance conductors. The ampacity of the service entrance conductors must be at least equal to the total load. It is important to note that the service entrance must be sized properly to ensure safe and reliable operation of the electrical system. An undersized service entrance can cause overheating, voltage drop, and other problems. An oversized service entrance is unnecessary and can be expensive. A qualified electrician can perform a load calculation and determine the appropriate size for the service entrance. In addition to the service entrance, the panel board must also be sized properly. The panel board is the distribution point for the electrical system. It contains the circuit breakers that protect the individual circuits. The panel board must be large enough to accommodate all of the circuits in the electrical system. The size of the panel board is determined by the number of circuits and the ampacity of each circuit. It is important to note that the panel board must be sized properly to ensure safe and reliable operation of the electrical system. An undersized panel board can cause overheating, voltage drop, and other problems. An oversized panel board is unnecessary and can be expensive. The qualified electrician can determine the appropriate size for the panel board. The main service disconnect switch is used to disconnect all electrical power from the building in the event of an emergency. This main disconnect should be readily accessible and labeled. Overcurrent protection devices such as fuses and circuit breakers are designed to protect the electrical system from overloads and short circuits. These devices are rated in amps and are selected to match the ampacity of the circuits they protect. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same voltage potential, which reduces the risk of electrical shock. Wiring methods refer to the types of conductors and raceways that are used to install the electrical system. Common wiring methods include non-metallic sheet cable, metal-clad cable, and conduit. Wiring devices, such as switches, receptacles, and lighting fixtures, are used to control and distribute electricity throughout the building. These devices must be properly rated for the voltage and current they will be carrying. Electrical boxes are used to enclose wiring connections and provide a safe and secure mounting location for wiring devices. Boxes are available in a variety of shapes and sizes to accommodate different wiring configurations. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical systems. The NEC is updated every 3 years and is adopted by most jurisdictions in the United States. Local electrical codes are regulations that are adopted by local jurisdictions to supplement or modify the NEC. These codes may address specific local conditions or requirements. It is important to consult with a qualified electrician to ensure that the electrical system is installed in accordance with the NEC and all applicable local codes. When calculating the total load, remember to consider all electrical equipment that will be connected to the panel. This includes lighting, heating, cooling, and other appliances. It's also crucial to account for any future expansion plans. If there's a possibility of adding more equipment in the future, it's best to oversize the panel accordingly to avoid the need for costly upgrades later. Another important factor to consider is the voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC specifies limits for voltage drop in branch circuits and feeders. To minimize voltage drop, use conductors that are large enough to carry the current without excessive voltage drop. You may also need to increase the size of the conductors if the distance between the panel and the equipment is long. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. Make sure that all metal parts of the electrical system are properly grounded. Bonding is also important for electrical safety. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same voltage potential, which reduces the risk of electrical shock. All metal parts of the electrical system should be properly bonded together. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices are rated in amps and are selected to match the ampacity of the circuits they protect. It's important to use the correct size overcurrent protection devices for each circuit. Using an undersized overcurrent protection device can cause nuisance tripping, while using an oversized overcurrent protection device can create a fire hazard. Wiring methods refer to the types of conductors and raceways that are used to install the electrical system. There are many different types of wiring methods available, each with its own advantages and disadvantages. The choice of wiring method depends on the specific application and the requirements of the NEC and local electrical codes. Common wiring methods include non-metallic sheet cable, metal-clad cable, and conduit. Non-metallic sheet cable, also known as Romex, is a type of electrical cable that consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Romex is commonly used for residential wiring because it is relatively inexpensive and easy to install. Metal-clad cable, also known as MC cable, is a type of electrical cable that consists of two or more insulated conductors enclosed in a flexible metal sheath. MC cable is more expensive than Romex, but it offers better protection against physical damage and is required in some applications. Conduit is a type of raceway that is used to protect and route electrical conductors. There are many different types of conduit available, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Conduit is typically used in commercial and industrial applications where there is a high risk of physical damage to the conductors. When installing electrical wiring, it's important to follow the NEC and all applicable local electrical codes. Improperly installed wiring can create a fire hazard or electrical shock hazard. Always use the correct size conductors for the application. The size of the conductors depends on the ampacity of the circuit and the length of the run. The NEC specifies the minimum size conductors that are allowed for different applications. Make sure that all wiring connections are properly made. Loose or corroded connections can cause overheating and create a fire hazard. Use the correct type of connectors for the application. Protect wiring from physical damage. Wiring that is exposed to physical damage should be protected by conduit or other means. Label all circuits clearly. This will make it easier to identify circuits in the future and prevent accidental disconnection of the wrong circuit. When working on electrical systems, always de-energize the circuit before working on it. This will prevent electrical shock. Use a voltage tester to verify that the circuit is de-energized before working on it. Wear appropriate personal protective equipment, such as safety glasses and gloves. This will protect you from electrical shock and other hazards. Be aware of your surroundings. Make sure that there are no flammable materials or other hazards nearby. If you are not comfortable working on electrical systems, hire a qualified electrician. A qualified electrician has the knowledge and experience to safely and properly install and repair electrical systems. The main point is that a 220 amp sub-feed breaker is not sufficient for a 450 amp load. Consider upgrading to a 450 amp breaker and appropriately sized feeder wires. Furthermore, remember that electrical work can be dangerous. If you are not comfortable performing the work yourself, hire a qualified electrician. They will be able to ensure that the work is done safely and correctly. Make sure to obtain any necessary permits before starting any electrical work. Permits are required for most electrical work and are designed to ensure that the work is done in accordance with local codes. Contact your local building department to determine whether a permit is required for your project. Remember, safety should always be the top priority when working with electricity. Follow all safety precautions and consult with a qualified electrician if you have any questions or concerns. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to determine the specific requirements for your electrical system and to ensure that all work is performed safely and in accordance with the NEC and all applicable local codes. Furthermore, remember to consider the nonlinear loads created by the electronic ballast used in the mentioned lamps, which also contributes to additional heat on the neutral conductors. The increased heat from harmonic currents created by nonlinear loads must be accounted for when calculating the load. Neutral conductors can overheat and potentially cause a fire. Consider also power factor correction to improve the efficiency of the electrical system. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased energy costs and reduced system capacity. Power factor correction can improve the power factor and reduce energy costs. Consider using energy-efficient equipment to reduce the overall load on the electrical system. Energy-efficient equipment uses less electricity to perform the same function as less efficient equipment. This can save money on energy bills and reduce the overall load on the electrical system. Furthermore, perform regular maintenance on the electrical system to ensure that it is operating safely and efficiently. Regular maintenance can help to identify and correct potential problems before they become serious. This can save money on repairs and prevent electrical hazards. Consider using surge protection to protect the electrical system from voltage surges. Voltage surges can damage electronic equipment and cause fires. Surge protection devices can help to protect the electrical system from voltage surges.